Today's honors geometry lesson is on section 5.4 on similar triangles. Our objective is to state and apply the angle-angle similarity postulate. From the previous sections, in order to prove that triangles were similar, you had to prove 6 different things. You needed to prove that 3 angles were congruent and that the corresponding sides were proportional. Using the angle-angle similarity postulate, you only have to prove that 2 of the 3 angles of one figure are congruent to 2 of the 3 angles of the other. So the angle-angle similarity postulate states if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. There's no need to prove the other 4 correspondence. Let's take a look at an example using the angle-angle similarity postulate. We are going to compare the 2 smaller triangles. So if angle ACD is congruent to angle B, then angle CAD is congruent to angle BCD. Therefore, triangle ACD is similar to what other triangle? The first thing we want to do is we want to redraw and relabel our triangles. So this is triangle A, and this is C, D, and we're going to take the other triangle and relabel that as well. So C, D, B. The next thing we want to do is we want to mark which angles are congruent. So if we start with our first tick mark, we can see in this triangle, angle C is congruent to angle B in this triangle. And for the 2 tick marks, angle A in this triangle is congruent to angle C in this triangle. So there we have our angle-angle similarity postulate. What I'm going to do now is I'm going to go ahead and mark the third angle congruent with 3 tick marks. Okay. So what I'm going to do now is I'm going to go ahead and complete the statement. So we have triangle ACD. So ACD goes from 2 tick marks to 1 tick mark to 3 tick marks. So we're going to follow the same pattern for the smaller triangle. So this triangle would be CBD. So C, B, D. So we went from 2 tick marks to 1 tick mark to 3 tick marks. So the next thing we might want to do is now that we have our congruency statement or a similarity statement, we want to go ahead and finish the last statement, which compares the corresponding sides. So using our statement, we can see that AC should now be proportional to CB, that CD is going to be proportional to BD, and lastly, that DA is going to be proportional to DC. So using the angle-angle similarity postulate, let's take the 2 smaller triangles and compare them to the larger triangle. So from the previous slide, we know that triangle ACD is similar to triangle CBD. So what we want to do now is write the similarity statement to the larger triangle. So again, I'm going to take this larger triangle and I'm going to redraw it. So we have angle A, angle C, angle B, and I'm also going to draw my angle marks that I know. So I know angle A is going to have your 2 tick marks, and then angle B down here will have the 1 tick mark. So therefore, in the larger triangle, angle C is going to have the 3 tick marks. So if we go back to the original similarity statements, so I'm going to go ahead and just mark these as well. So if we take triangle ACD, which is the medium triangle, so ACD goes from 2 tick marks to 1 tick mark to 3 tick marks. So when I label my larger triangle, I'm going to follow the same pattern, and that's going to give us that triangle ABC is similar to triangle ACD and similar to triangle CBD. So now what I'm going to do is I'm going to compare the medium triangle, which is ACD, to the larger triangle and complete the similar sides. So AC should be similar to AB in the larger triangle. Okay. CD should be similar to BC in the larger triangle. And DA should be similar to CA in the larger triangle. So using what we know about the angle-angle similarity postulate, let's find the missing sides of a triangle or missing segments of a triangle. So we know that AB is going to be parallel to DE, which means that angle A is going to be congruent to angle D based on corresponding angles. We know that angle B is going to be congruent to angle E here because of corresponding angles. And then since both triangles share angle C using the reflexive property is going to be congruent to itself. So now we know that these triangles are similar based on the angle-angle similarity postulate. So what we're going to do now is we're going to write our similarity statement. So based on the tick marks, we know that triangle ABC, which is the larger triangle, is similar to triangle DEC. And this is going to help me come up with my scale factor so that I can use the scale factor to find the values for x and y. So before I do anything else, I'm going to go ahead and write which sides in the bigger triangle are similar to what sides in the smaller triangle. So I know that AB is similar to DE, also that BC is similar to EC, and lastly, that AC is going to be similar to DC. So it's very important to always write your congruency statements for your angles if you're finding your angles, and your similarity statements for your sides if you're trying to find your sides. So we do not need to find the congruency statements for the angles since we're not trying to find the angle measures in this example. So the next thing I'm going to do as my second step is I want to find the scale factor. So looking at the triangle, I know that AB is similar to DE. I know that AB has a length of 40 and DE has a length of 16. So if I simplify, I know the scale factor from the larger triangle ABC to the smaller triangle DEC is 5 to 2. The next thing we're going to look at is where x is. So x is the length from A to D, which happens to just be part of the side of the triangle. So when I go to find this, I'm going to call the whole length of AC, let's call this Z. I don't want to use x in my proportion because I don't want to confuse x with the length of AC versus the length of AD. So I know that if I need to find the length of AC, that's going to be similar to the length of DC based on my similarity statements. So if I use my scale factor, so 5 over 2 is going to be equal to the length of AC over the length of DC, which is 4. And now I can cross multiply and solve my proportion. So 2Z is going to equal 20. And the length of Z is going to equal 10. So remember, if Z equals 10, I just want to find the length of x. So I know the length of DC is 4, the length of AC is 10, so 10 minus 4 means that the length of x is 6. So the length of x here is 6. Okay, so now we can use the same scale factor to find the length of y. So we're going to call this our fourth step. So using the same scale factor of 5 to 2, if I look at the length of y, that segment CB or BC, and we know that BC is similar to EC, so when I set up my proportion, I'm going to put 20 over y, and then we're going to cross multiply, so 5y equals 40, which means that the length of y, or the length of CE, is 8. So the length of CE is 8. So for the last example, we're going to complete each proportion below so that it will lead to the following equation. So BC times XY equals AC times ZY. So remember with proportions, we cross multiply. So if we have BC over ZY, and I need to set up a proportion, I know that we have to cross multiply so that BC is going to be multiplied by XY. So that means XY is going to go here. And I also know that ZY has to be multiplied by AC using cross multiplication. So AC is going to go right there. And we're going to follow the same procedure for the second proportion. So I know that XY has to be multiplied by BC. So to cross multiply, BC must go here. And if I want to multiply AC by ZY, that ZY has to go right there. So from the proportion above, we can conclude that triangle ABC is similar to triangle XZY. So this is the end of the lesson. If you have any questions, watch the video for a second time. And if you still have questions, write down any of those clarification questions that you may have and bring them to the next class.